Hello guys, uh, welcome to a new video. In this video, we will be going through how an SQL plan is generated and is converted into code that runs for a Spark job. So how the plan is generated, which plan is used, and why it is used. So that kind of things. We will go through this whole process that is there. We will go through each of the units in detail. But before doing that, there are certain things that I will like to talk is this diagram is helpful for people who are interested in making changes to the Spark code base to suit their requirements. And this also helps people who are trying to add or remove certain rules, let's say in AQE or let's say in planning phase, so that this helps in understanding internals. So, for example, if we want to exclude any rules, where does that happen? Like, does that happen before, after the physical plan creation and stuff like that? So this is something a deep dive into that. Uh, so let's see how we will deep dive into this itself, and let's see how plan is created for an Spark job, beginning from SQL and see how it goes. Okay, so uh, let me hope you can see my screen. So if you see, the first we have a SQL string that comes to Spark for its planning. Then what SQL does, what Spark does, it uses lexers and parsers to create Antler parse tree, which is again, as I mentioned, it creates a logical plan of the SQL that has been received. This antlered parse tree has a listener method, a listener class, which has two methods, entry and exit. So for each time a token is there, what should happen with that is decided in here. This generates an unresolved logical plan. We will go through this in details as well, what unresolved logical plan means. But basically here, as of now, Spark does not know which is, it does simply have an indexed items. It doesn't know how to resolve that, like what does a column or what does a table mean. So that information is not there yet. Then it starts with the resolver. Basically, this resolver is what it will resolve an unresolved logical plan. So it will resolve all the indexes, all the items which are numbered, and then it will make a sense using the metadata catalog that okay, which this relation means what. Like for example, if it says a table name, this what does that table have? What does it mean? What is column name and all. So once it is having that, so it has an analyzed logical plan, and this analyzed logical plan has resolved relations and references. For example, talking about tables, schema, database, joins if we are using. So all those things have been resolved in here. It also uses a cache manager and optimizer at this phase to the logical plan. Cache manager is just to see whether if there is anything already cached for this plan, or let's say if it is there, if certain things are being used from cache. For example, let's say the in first step we already had that query that was cached, so that the cache manager tries to find out what things can be used from caches. Then it creates an optimized logical plan. This logical plan, when we say optimized logical plan, has a lot of query rewrites, predicate push down. So all those, and there are 75 different rules, more than 75 rules, which gets applied in here to create that optimized logical plan. And once we have the optimized logical plan, we come with AQE. All these 75 rules are static. So these are not dynamic. These are rule based. Then comes the AQE, which is dynamic in nature. It looks at the stats and then decides on what to apply as uh, optimizations further. And it uses, so AQE, first AQE comes in, then Spark Planner comes in, and then it creates a physical plan. So physical plan is, so there are many physical plans. That's why it is physical logical plans, because it goes through a CBO process. Uh, CBO process is nothing but cost-based optimizer. So out of those physical plans that gets created, based on the cost-based optimizer, it decides which plan will be the most suitable one, and that plan gets executed. So not executed, the plan is selected for execution, and then we have a Genino compiler. Basically, this compiler uh, is used for the whole stage code generation part. Basically, all things that we have written is a single big Java function that gets created and that gets executed as a code. So this is how basically the whole plan looks like. Let's go ahead and see what those individual things mean uh, further. Okay, so here we see whatever we have mentioned is all in here. So now see the SQL parser, as I mentioned, is an Answer parse tree. It Spark Engine, as of now, when it creates, it doesn't know what is object is there or not. So in Spark code base, these are all under the SQL folder. So catalyst, analysis, plans, everything is present in this folder. This I have mentioned because I had to find out where all these rules are defined, and so this is where everything is present. The past logical plan, when it does, the syntax error are cached in here. So when we have this this parser, if anything syntax wise, if anything is wrong, it will be uh, identified here. And then we will have analysis exceptions, which is at the analysis layer. So when we are doing this, it uses the catalog and it will use the DB, whatever is used to identify which relation is there or not. So any errors that comes for file resolving. So for example, you might have seen analysis exception, column not found or table not found. So those things come in this analysis phase from this page itself. As I mentioned, see here, resolve logical plan, columns, tables, interpretations in the query exist in the catalog. If it is not, then we will get the analysis exception. Then we have optimization. So the optimized logical plan is done by the catalyst optimizer. And here we have, it goes through a lot of optimization predefined rules which are there. And this is sample some rules, for example, column pruning, join reordering, eliminating the sorts, predicate push down. So these filters are, all these optimizations are applied in here. For example, here it says max of distinct column name, and this is distinct is useless because let's say if someone writes like this, that okay, I want the get the maximum of the distance values. This distinct is redundant. This is not used. This is so. What it will do in here, it will just remove this distinct, eliminate the distinct rule because it is unnecessary. Because anyhow, max calculation doesn't not depend on distinct. So that is one kind of rules which is there, which optimizes the joins. Let's say if we want to remove certain rules, there are cases where we might want to remove certain optimization rules, catalyst optimizer rules that we don't want to happen. So that can be done. For example, here if we say in Spark conf, we can say this exclude rules is a config key, and then we can pass the list of rule names. So basically it is, as I mentioned, it is present in the Spark SQL folder. So after that we have catalyst optimizer push down predicate, and we have another one. So we can, if we want to remove these rules, uh, generally which is will not be needed, but I have seen a few examples, a few cases where I had to exclude explicitly because the job was running a lot slower because of this. So once we remove that, it worked. Uh, so this is where this is how we can set certain rules to be excluded, and certain things like some summary is there, like what each means was the common ones do as an optimization, uh, for example, one join reordering. So this decides okay whether the order in which we are doing the joins can be optimized For example, let's say we have three joins, three table join, and we have the bigger table on the left side, then smaller table on the right side, and then we have another join, but the join that we are doing is on the lesser data set. So instead of doing a bigger join, two bigger joins first and then doing a smaller join, we can do first smaller join and then do the bigger join. That way we will be reducing the number of rows that we will be fetching. So that kind of join reordering happens in here. As I mentioned earlier, we have seen in the flow as well. After these rules are optimized, the physical planner kicks in and it converts more than one candidate physical plans, and those physical plans are ex those physical plans are generated, and then the CBO, which is the cost bet optimizer, looks at those physical plans and identifies which one will be the least expensive in terms of CPU and IO costs, and that plan is selected, and that uh, plan here we decide on the join strategies. For example, and let's say the physical plan is to create. We are joining two tables, so here it will decide whether it will be a broadcast join, sort merge join, so storage partition join. So what kind of join that happens at the Spark this time. So this is one. Other one is hash aggregate versus sort aggregate. That happens. This is also in the physical planning itself. Once we have the physical plan and the CBO has decided, okay, we will execute this particular plan. It creates it 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 first starts to do the requirements, whatever is needed, and so there is a class called install requirements rules. There is a rule which says install requirement class, which does the all the prerequisites for this execution. And once we have that, all the requirements are complete, means met, we do have a, whole stage code generation pipeline that kicks in. This generates multiple operations into one single big Java function, and that's how it gets applied. And this code generation is done using as we saw Genino compiler, and we have seen cases where the Spark jobs runtime may be increased, or maybe sorry, the job times can be reduced if we use a better compiler, but that is not that significant. But yes, we have seen cases where we had to upgrade our Genino compiler, I think, from some lower version to higher version to gain some speed up. So that also happens at this layer. Now, once it is there, we can see the plans for a particular SQL, what is uh, going to be executed. And when I say SQL, it is not only restricted to SQL. Data frames operations also work in the same way. So we have multiple options. For example, if we have df, we can say df.explain, and then it will give all the uh, uh, whole plan, like what is the past logical plan analyzed. So see, if you see, it is say from the top to bottom, that okay, what is the past one, what the analyzed one, then what was the optimized one, some status, and then what was the physical plan that gets executed. So uh, this is how things work. And for example, as I mentioned, there are extension points which we can use to add our custom optimizations. For example, if we want to use some other parser other than Antler one, we can implement that. We have option of adding custom analyzer rules, custom optimizer rules, and Spark strategies, like Spark strategy of using which join types to implement. So this is how uh, we can extend this capability, and this is how the code gets executed with Spark. And hope this was helpful. Uh, Feel free to read this blog, and thank you.